So it's a great pleasure to welcome the next speakers, Viktor Shynkarenko and Larysa Zhuchyi. Semantic checking of different types information sources about permitted speeds in railway transport, Ukrainian State University of Science and Technologies. So you're welcome.
Can you see my screen?
Yes.
Semantic checking of different type information sources about permitted speed. It's in railway transport. Authors Viktor Shynkarenko and Larysa Zhuchyi. Permitted speed on the railway track section depends on many factors, such as the rail type of the track and the probe type of the railway switches and their condition. The description of infrastructure elements and their speeds are represented in documents of various formats: drawings, databases, Microsoft Word documents. Consistency checking of the permitted speed and the track characteristics is carried out according to the legal documentation presented in the form of non-formalized restrictions of natural language texts. The purpose of the work is to check the consistency of the railway track permitted speeds with the characteristics according to the regulatory documentation rules by ontological means, which helps to improve the safety of the railway train traffic. According to this definition, a modular railway track ontology has been developed with the gradual addition of properties. I have some troubles. Second. According to this definition, a modular railway track ontology has been developed with the gradual addition of properties during the ontology formation. Railway transport ontologies receive a lot of attention. For example, there are rail core ontology and rail topology ontology. Rail core ontology is based on the international standard RailML and is used to integrate train timetable data, maps, and GPS to locate faulty trains. Rail topology ontology enriches the international UML standard rail topo model and is used to integrate railway infrastructure data. It should be noted the lack of attention paid to the legal support of the transportation process developed in ontologies. We have developed ontologies of 3 levels presented on the slide. The abstract level is represented by a vocabulary. The first level concretization models are enriched with rules and data. T-box of the ontology schemas are completed. Vocabulary classes are associated with instances. In the second level concretization models, rules are associated with a data set. The presence of the second level of concretization makes it possible to form several ontologies based on a single ontology of the first level with the introduction of different data. The formation of the ontology is carried out in the following sequence. United vocabularies are developed to describe the table structure. The abstract resources model ontology is shown in the diagram of the procedure for forming a modular ontology of the railway infrastructure. The abstract resources model includes the names of the tables, columns, and station attributes. For example, the class of the track with tables, the track number, then track name, columns, and the Nizhny Dniprovsk Uzel station attribute. The vocabulary is developed to describe the railway infrastructure. The abstract railway infrastructure model ontology is shown in the diagram of the procedure for forming a modular ontology of the railway infrastructure. The abstract model of the railway infrastructure has the concepts of railway tracks and lines, switches, frog types, track names, permitted speeds. Rules for validating structure of tables, classifying tables by type, program, and station are formalized. Ontologies of a concrete resources model that includes rules are presented on the diagram of the procedure for forming a modular ontology of railway infrastructure. Tables validation is performed using the SVRL rules for cells containing the error literal. In our research, the following software tools were used to develop ontologies: Protege, MLCube, OpenIFind, Tabula, Sumat, SQLite, and Inception. The approach is to transform some of the restriction of legal documentation into a TSV notation. Table headers are manually described. The table headers ontology of a concrete resources model is that includes data is presented in the diagram of the procedure for forming module ontology of railway infrastructure. The structure rendering model ontology of the concrete resources model is presented on the diagrams for the procedure for forming a modular railway infrastructure ontology. In the second level concretization resources model ontology, the instances of the table headers and rules for classifying by type and program are imported. In the class annotation, one gets open refined scripts to transform the table structure. The part of the instances representing the structure of the table is generated in OpenIFind. The table structure ontology of the concrete resources model is presented in the diagram of the procedure for forming a modular ontology of the railway infrastructure. In the ontology of the second level concretization resources model, data validation is performed. The structure validation model ontology of the concrete resources model is presented in the diagram of the procedure for forming modular railway infrastructure ontology. The rules for classifying tables by station are loaded in the ontology. Data wrangling scripts are got in the annotation for classes. The data wrangling model ontology of the concrete resources model is presented in the diagram for the procedure for forming modular railway infrastructure ontology. In OpenIFind, the first part of the concrete railway infrastructure model ontology that includes data is generated. The building norms and table with data ontologies of the concrete railway infrastructure model that includes data are presented in the diagram for the procedure for forming a modular ontology of railway infrastructure. In OpenIFind, the second part of the ontology is generated based on the annotations of the normative document. The ontology of railway technical exploitation rules of a concrete railway infrastructure model that includes data is presented in the diagram of the procedure for forming a modular ontology of railway infrastructure. Table linking rules are formalized. The matching rules ontology of a concrete railway infrastructure model that includes rules is presented in the diagram for the procedure of forming a modular railway infrastructure ontology. The means of improving the safety of train traffic are proposed based on the semantic checking of data from various sources on the permitted speeds on the railway elements. Relation compositions are used to link the track and switch list by relation compositions in such a way to obtain effect controlled by the technical exploitation rules, that is to associate the track names with the railway switch frog type of the track. Relation compositions are used to link the track list and speed tables in such a way to obtain a fact controlled by the building norms, that is to associate the track rel type with the line section speed. Instances, data tables, and output file for notating the rules for technical operation rules for linking tables and checking data consistency are imported in the ontology. The data integration model ontology of the concrete railway infrastructure model is presented on the diagram of the procedure for forming modular ontology of railway infrastructure. In the concrete railway infrastructure model ontology, the consistency of the declared immediate speeds of the track section and the track characteristics and compliance of track with the technical exploitation rules is checked. A modular railway track ontology has been developed using compositions of the relations. Checking the consistency of the declared speeds and characteristics of the railway structure with railway technical exploitation rules and building norms in the relevant information systems is carried out. It is planned to develop checking the consistency of the permitted speeds and the condition of the railway track. Thank you for your attention.
Thank you for your presentation. So dear colleagues, do you have any questions to the presenter? Okay, if there are no questions, let's proceed. So the next speakers, Khrystyna Mandziy, Uliana Yurlova, and Marianna Dilai, English-Ukrainian Parallel Corpus of IT Texts, Application in Translation Studies, Lviv Polytechnic National University.
Yes, good afternoon, everyone. So just a minute, I'm sharing my presentation. Can you see my screen?
Yes.
Okay, so honorable participants of the conference, let me present the results of our study English-Ukrainian Parallel Corpus of IT Text, Application in Translation Studies. The topicality of our study is determined by the importance of the development of Ukrainian corpus linguistics, in which there is still a large gap in the parallel Ukrainian foreign corpora construction, and there is a rapid growth of the information technology sphere in Ukraine, and IT terminology is changing and evolving rapidly. The translation of such terminology from English into Ukrainian needs additional attention. We see the theoretical value of the study in expanding the scope of research on IT terminology, defining and systematizing the peculiarities of its translation from English into Ukrainian, and the practical value of the research is that the parallel corpus of IT text and the macro program which have been created during the study will be useful for linguists, translators, and specialists in the field of information technology. So the research object is a parallel corpus of texts in the field of information technology. The research subject peculiarities of the parallel corpus creation and practical application of its data for translation of IT terminology. The study was based on the text of 5 programming textbooks and 2 sites with technical documentation for the Bootstrap framework and the PHP scripting language. Total more than 3,000 words. So the corpus linguistic techniques, including keywords, collocation, and concordance analysis, are used to extract a list of key IT terms in the corpus and determine their linguistic properties. Furthermore, a contrastive analysis of the extracted English IT terms and their Ukrainian translations is carried out, focusing on their common and divergent semantic features, metaphoricity, and structural types. The procedure of the parallel corpus creation using Corpus Manager and Text Analyzer sketch engine included some technical standardization and formatting of text and aligning sentences with their translations. It should be noted that the corpus contains more than 10,000 aligned sentences. Figure 1 presents general quantitative information about the English and Ukrainian parts of the created parallel corpus. So the next step was to retrieve key IT terms from the created parallel corpus. Keywords are the words that are more frequent in the corpus in comparison with the reference corpus. Sketch engine makes it possible to extract the list of keywords automatically using keywords function. The referent corpus in our case was the British National Corpus, and for the further linguistic and translation analysis, we used the top 205 English terms extracted from the corpus. The last step was to find Ukrainian equivalents to the key IT terms in English using the parallel concordance function. This feature made it possible to trace the use of terms in context and to determine the methods of translations of each terminological unit found. We have also developed a macro for text analysis, which will allow the user to quickly use the database of English-Ukrainian parallel corpus of AT texts to translate their own text in the Microsoft Word editor. We have used Environment Visual Basic for applications to build the macro program. The macro searches the text for words given in the glossary of the key IT terms and add hyperlinks to the corresponding concordance in Sketch engine. Figure 4 shows a model of the process of using such a macro by the user. Figure 5 presents the text processed by the macro, and words from the text were found in the glossary of key IT terms. Each term has a hyperlink which leads to a concordance of the corresponding term. And figure 6 showed the concordance constructed for the word syntax. The user is redirected to this concordance when clicking on the hyperlink added to the text in the Microsoft Word. So the created macro gives the access to parallel concordances for words directly from the Microsoft Word editor, and this program significantly saves time by working with the text. By opening the concordance in Sketch engine, the user can quickly get acquainted with the context of terms usage and possible translation options. We have also analyzed 205 IT terms in English and their translations into Ukrainian in terms of type and method of translation, and established that the most typical for the translation of IT terminology are the following methods: transliteration, calc, explication, and equivalent methods. The most common translation method used in this investigation is calc, or loan translation. As a result, we found out that 84 out of 205 terms were translated using this method. So let's move to the analysis of lexical semantic groups of IT terms. The analysis of lexical semantic groups of 166 noun terms was carried out on the basis of the classification proposed by Mandziy. So we differentiated names of knowledge areas, for example, programming and functional programming, names of specialists, for example, programmer, names of units of information, for example, byte, software names and their element, which include types of application software, for example, constructor, installer, and software elements, for example, command line, flagging. Also terms related to the process of working with information, for example, caching, import, and terms related to the internet and internet communication, for example, browser, cache, and so on. The groups of terms described above make up only 27% of the studied noun terms. The rest of the terms cannot be attributed to any of the selected groups. So having analyzed them, we distinguished three more groups: terms of programming theory, names of graphic interface elements, and names of graphic symbols. The most numerous is the group of terms of programming theory, 88 terminological units. Figure 8 shows a pie chart illustrating the quantity ratio of lexicosemantic groups of the key IT terms in the English-Ukrainian parallel corpus. The next stage of our study was the analysis of metaphorical IT terminology in English and Ukrainian. The research material contains 166 simple English terms and their Ukrainian equivalents, among of which 85 English and 72 Ukrainian metaphorical terms were identified. The sample analysis showed that IT terms are often formed by metaphoric rethinking commonly used words and phrases. We have distinguished the following source domains of metaphorization. Among them are clothing items, household items, tools, places, people, nature, actions and states, signs, social life, position in space. In 14 cases, we trade the change of the source domain when translating metaphorical terms. The table 1 presents the results of quantitative analysis of source domains for the metaphorization of IT terms in English and Ukrainian. Comparing English metaphorical terms with the Ukrainian equivalents, we concluded that in most cases, 68%, the terms retain their metaphoric meaning in both languages. So let's speak about structural types of IT terms. Simple terms make up the majority of the studied list of the English terms. 70%, among them 1/3 are non-derivative terms and 2/3 are derivatives. Most of the English compound terms have the structure noun plus noun, for example, placeholder, followed by the modal adjective plus noun, for example, white space, and also verb by adverb, for example, drop down. Most of these terms are translated into Ukrainian by changing the structural model. A complex term consists of several elements that are connected in some way. Among them, the most productive are two-component models. It should be noted that there are more Ukrainian complex IT terms in our sample than English ones. And also we conducted part of speech analysis of IT terms. The part of speech analysis of terms made it possible to establish the relationship between parts of speech in the terminological system. We have revealed a tendency in IT terminology to nomination. The prevalence of nouns in IT terminology is explained by the fact that terms mainly perform a nominative defining function. And the results show that nouns are followed by verbs 11%, adjectives 8%, and adverbs 1.5%. In general, 93% of simple terms retain their part of speech affiliation during translation. So in the course of our research, using the data and features of the created English-Ukrainian parallel corpus of IT texts, we made an attempt to single out the most common methods of IT terms translation and their linguistic peculiarities. The corpus manager sketch engine was used to provide convenient and fast access to the corpus, and furthermore, a macro program was created for the translation of IT text in the text editor Microsoft Word. The key English IT terms were obtained using the methods of key words and were analyzed in terms of lexical semantic groups they belong to, as well as sources of metaphorization, structural type, and part of speech affiliation. The paper outlines the advantages of using a parallel corpus during translation and encourages further improvement of the parallel corpus in accordance with certain translation needs in order to achieve the highest level of equivalence of the translated text and the original text to meet the expectations of the translation recipient. The study opens up prospects for further research on the parallel corpus in order to identify new useful means of facilitating the work of translators, and we see the prospects in the further expansion of the text base of the created English-Ukrainian parallel corpus of IT text. This will contribute to its greater representativeness and further linguistic and translation study of English and Ukrainian IT terminology. Thank you for your attention.
Thank you for your presentation, dear colleagues. Do we have any questions to the speaker?
I have a question. May I?
Yes, of course. Of course, you're welcome.
A small technical question. First of all, thank you for the talk. I'm happy to hear about the Ukrainian parallel corpus. About the program, when you show the parallel text English-Ukrainian, there was a term syntax, and in the translation of the term was highlighted. I wanted to ask if the program did it.
It is the slide number 8, right? Or
this yellow marking.
Yellow marker, no, this is sketch engine program, and this is a concordance in the sketch engine. And our program, it is the macro in the Microsoft Word, and it only adds links to the main IT terms in the document, and then you click on this hyperlink and you go to the parallel concordance in sketch engine.
And you, in Sketch Engine, you search for the English word, and the program highlighted the Ukrainian word.
I think this is done automatically by Sketch Engine. When
Yes,
you,
and this yellow color is by
yes.
Yes, thank you. Thank you.
Thank you for your question.
Thank you. So do we have any other questions to the speaker? If no, let's proceed with the next speakers. Mariia Hryntus and Marianna Dilai conducted a research translating emotion metaphors from English into Ukrainian based on the parallel corpus of fiction. You're welcome.
Hello, let me share my screen.
I have already done it, so everyone can share the screens.
Yeah, do you see my presentation?
Yes. Yeah, we can see.
Thank you. So, dear participants of the Colins conference, let me present my research devoted to translation of emotion metaphors from English into Ukrainian. And translation from one language to another might be difficult because of different distinctions in the source and target languages affected by cultural variations. And one of the most challenging tasks is to translate a metaphor, a figure of speech characterized by rich diversity across and within culture. And this research paper devoted to its aim to examine how emotion metaphors function in English and Ukrainian and what concepts they embed. This one. And it's devoted to the study of emotion metaphors translation from English into Ukrainian based on the parallel corpus of fiction. And because the analysis of large volumes of data allows us to make clear conclusions about the main metaphorical source domains of the analyzed text and also the specifics of their translation. And in our research, we focus on the application of the parallel corpora. First, we outline and collect the metaphorical source domains of basic emotion metaphors, and then we analyze differences between emotion metaphor functioning in Ukrainian and British fiction, and also the specifics of their translation. And moreover, we also compare main metaphorical source domains of those outlined emotion metaphors. But let's come back to some theoretical background. That says that emotion concepts are composed of several parts. Those are metaphors, metonymies, related concepts, and also cultural models. But in contrast, Dilai bases claims on an unsatisfactory kind of linguist in which emotional language consists only in literal emotional words, such as fear, anxiety, and so on, and that classify and refer to a pre-existing emotional reality, the brain states and body response. And not only Dilai, but lots of scholars and linguists dealing with emotional language suggest that this language simply consists of a few words. And of course, speakers of some language are also appeal to feel that some of emotion may be more basic than the other. And it can be outlined that there are 6 universal emotions. Those are happiness, anger, fear, sadness, surprise, and disgust, and that are accompanied and can be also distinguished by some universal facial expressions and also physiological reactions. Also, different methods can be used to probe a corpus for figurative expression used to talk about emotion in a given language. And one option is to focus on specific emotion words of the domain under security. And for example, to study the domain of anger in English, One might select words like anger, fury, indignation, frustration, and so on. And once the target words are identified, we can retrieve from the corpus all the sentences in which those words are employed. And this usually involves numbers to hide from manual inspections, but a typical approach in the field is to analyze 100 of them randomly selected from a full list. So our research consists of such stages. In the initial stage of the process, we are to apply parcel corpus for further study, and the research material consists of the research results for basic metaphorical expression domains functioning in the English language. In general, the amount of our sample is 200 abstracts. And when the metaphors were outlined, we are to collect them and form a sample, taking into consideration the text in English and its translation into Ukrainian provided in the corpora. And as soon as those steps have been carried out, the specifics of the metaphor's translation into Ukrainian are under study. We are to analyze the translation and outline the main metaphorical expression domains of the emotion metaphors in English and British fiction. And here you can see the parcel interface. Parcel includes morphosyntactic and other linguistic annotations such as lemmatization for many languages, what gives us additional opportunities. And here is all for the corpus build, an example of corpus built for the law query. And firstly, we make a corpus for each of the basic metaphors of emotion. Thus we get results for anger, sadness, fear, happiness, disgust, and surprise emotions. And the first concept taken into account is anger. Lakoff and Johnson claim that anger is a heat of a fluid in a container, and this is the central metaphor in the conceptualization of anger. In the data collected, we find the following expression illustrating this conceptual metaphor. And analyzing the examples given, we can outline that in the first sentence, the word erupting, describing anger breaking out suddenly and dramatically, was omitted, and it was not interpreted in the Ukrainian translation. Thus, the deleting strategy of metaphor translation was used. And as of the second sentence, we can see that the original text and the translation provided are quite different. And if in the English text we know that anger fills a hut, in the Ukrainian, the hut is meant to be filled by an angry man himself. And the next emotion metaphor we are to discuss is fear. Self as a container metaphorical expression is represented in the sentence outline, and reproducing the same image in the target language strategy was used in this example because ohopevstrach literally means gripped by fear, and also function as a metaphor in Ukrainian. And to outline metaphors needed, we have also taken into consideration the following sadness metaphors. The sentence given is an example of the metaphorical expression domain of sadness as a fluid, and the translation provided has personification. What is in particular a form of metaphor? And the last word with negative meaning we are to discuss today is disgust. Although disgust is commonly classified as one of the basic human emotions, it has received relatively little attention from linguists in comparison to other emotions. And metaphorical expression disgust as a fluid is used in this example. Speaking about the translation, it also represents the disgust as a fluid dropping, викапуючи in Ukrainian, and being an acid, мов пекучу кислоту in Ukrainian. Also, the translation strategy, image reproducing strategy was used here. And considering the examples of metaphors with positive meaning, we are to begin with one of happiness emotion. And as we observe here, the metaphorical expression based in happiness was used to express happiness being a fluid in which somebody or something can be based like it is water. And in the translation given, replacing image in the source language with a standard target language image strategy is used. The Ukrainian opovate radisti is a metaphorical expression frequently used in fiction. And the most frequently used metaphor in the corporate form is to be in love. So again, this is an example of emotion represented as a container. And in Ukrainian, it's usually translated as zakohata sebu. And the last emotion used in the research is the one of surprise. The language and metaphors of surprise was studied by Kendrick Murdoch, and in the sample collected, the most frequent domain was a surprise as a national force. And in the translation provided, the metaphorical expression is omitted, but nevertheless, the sense is saved in the translation, so converting a metaphor into its sense strategy was used. And the analysis of the sample showed that surprise is the least metaphorically comprehended concept in the list outlined, and it's not very complex social phenomena, so there is not a great amount of conceptual content to be associated with. And the disgust emotion has also received relatively little attention. And speaking about another concept of positive meaning, the concept of love is perhaps the most highly metaphorized one, and the most frequently outlying domains in our sample are emotion as a container and emotion as a fluid in a container. And speaking about the strategies of translation, they're producing the same image in the target language strategy was used in most cases. The main domains of emotion metaphors were usually saved or interpreted with the metaphors representing the same image in the Ukrainian language. Only in few sentences the strategy of omission was applied and no equivalent was used. And I hope that results and conclusions will contribute to the understanding of emotion metaphors domains in English and their translation into Ukrainian. And for now, thank you for your attention.
Thank you. Thank you for your presentation. So
Thank you.
You're welcome to ask questions. Do we have any questions? So if no, I have one. Have you analyzed such examples when one metaphor was translated in two different ways? So different translation strategies were applied while translating metaphors.
Actually, I haven't. I can't remember any of those examples when two different strategies were used, because usually the translator uses the same pattern, you know.
Okay.
So I can't remember any of that examples. Thank you.
Thank you. So let's proceed then with the next speakers. But due to the time limit, we have to redial. Please join the meeting once again.